All right, George, let's take a look at this vector stuff. Now, you got to understand that vectors are the language of physics. It's either vector or scalar. Scalar, just you have to deal with the magnitude only, and you don't care about the direction. Vectors, you have to care about the magnitude as well as the direction, unless it asks you for magnitude only. So it's kind of a big deal. So pay attention. There are a number of ways you can do this. I'm going to show you as many different ways as I can come up with. Your teacher may want you to do it a single way. I don't really know, but I'll show you what I can do with it. All right? So, number 1 says, for the vectors drawn below, which statements are true? So they give you a parallelogram, and then they give you the diagonals on the parallelogram. All right? So this is side B, this is side A, this is side F, this is side C, and then you have the 2 diagonals. I'm going to wait on the 2 diagonals. So what I know is that I have C drawn in the wrong direction, so let's fix that real quick, because your picture shows it down and to the left, and that's not what I drew. I've got F drawn correctly. I've got B and A drawn correctly, so we're doing good so far. All right, so statement A says that A plus B equals D. Well, here's A, here's B. If D were drawn like this, that would be a correct statement. However, your D is drawn like that. So if I added B and, let me see if I can draw that a little bit better. If I added B and A, there's my B, there's my A. D would need to be drawn so that the head of D touched the head of A and the tail of D touched the tail of D in order for it to be a true A plus B equals D. So, if you just think about what's going on, B is acting to the right and in an upward direction. So I have upward and to the right for B. Because if you look at it, it's really made up of a leg. That's like the hypotenuse of a triangle. There's a leg and there's a leg. And the sum of those, by and bx, if you did Pythagorean theorem, you would get B. Okay, so B is acting straight up and to the right. A is acting to the right. So there's no way that D can be down and to the left. That doesn't make, it just makes no sense. It's like you push a package this way and then you push a package this way. It's going to wind up in this position over here, which is up and to the right. But the way D is drawn in the question, they have it down and to the left. So A plus B does not equal D. All right, and then it says A plus B is equal to a negative D. All right, let's see if that makes sense. So here's my A, here's my B, so there's B plus A, or A plus B, same thing, order doesn't matter. So I've got the head of B touching the tail of A, and then they say that equals a negative D. Well, let's look at D. D is that way, so, I'm sorry, D is this way, down and to the right, so that's D. A negative D would be in the opposite direction, which would be up and to the left. So that's a negative D, and B plus A does indeed equal a negative D. So that's correct. All right, choice C says that B plus E equals C. Well, let's look at that. All right, so B is up and to the right, plus E is down and to the left. So there's our down and to the right. So there's E, there's B, and so I've got them head to tail. So if I want that to be added, B plus E, that has to be the sum of B plus E. And they say that B plus E is equal to C. Well, this looks more like F to me. So I would say that B plus E is equal to F. Well, let's see if it is possible for B plus E to equal C. All right, so no, there's no way. If you look at that, B plus E cannot equal C, because if you look at your original triangle, B and C, this would be the way C is drawn. B and C are the exact same size. They're in the exact same direction. So there's no way that can be a true statement. All right. Let's move on to D. F plus C is equal to A. So F is here. Let's go down a little more. So F is a straight line pointing to the right. C is down and to the left. So there's F. There's C. And they want to know if that equals A. Well, A is up here. A is the exact same magnitude as F, exact same direction, so F plus C cannot equal A. So follow it through, see if you can figure out the rest of those. I have a sneaking suspicion you will. That'll take us through number 1. All right, let's look at number 2. Number 2 says, well, actually you have 2 number 1s, so let's see what's going on. Adding perpendicular vectors. So I want to add 5 newtons and 12 newtons. So I have 5 newtons, and then I have 12 newtons. 5 newtons is to the north, 12 newtons is to the east, so their sum is going to be Pythagorean theorem. 5 newtons squared plus 12 newtons squared. I believe that's 169. Square root of 169 is probably 13. And I'm going to call that the resultant, because that's what we call the sum of a bunch of vectors is the resultant. This is the resultant right here. I draw mine with a dashed line. Now, I'm not done. I need to find an angle theta, so I can do that in a couple of ways. If I wanted to come back in here, I could draw a parallelogram. Thought that was going to green. I could draw a parallelogram. That would be 12 newtons. That would be 5 newtons. And I always want to talk about the angle that's formed with the two tails. So I'm going to call that theta. So that could be theta. I could do it here, and I could call that theta. So I'll look at both of them, because I'm going to show you how they are saying the exact same thing. Okay, so the tangent of theta is equal to the side opposite, 5, over the adjacent, 12. So when I do that on the calculator, I think I'm going to get around 37 degrees, but let me make sure I'm not lying to you. Make sure your calculator is in degree mode, and get a calculator that has some batteries at work. I'll be right back. Oh. Okay, so I went and got a calculator that worked, and I punched that in, and it actually is 22.6 degrees for this theta right here. All right, well, if that's a right triangle, that's a right angle right there, then 90 minus 22.6 degrees is the same thing as 67.3. So I'm going to make sure again that I didn't make an error. 67.4, 67.3, close enough. All right, so even though I got an angle, I'm not done. I haven't talked about the direction yet. So I can say that this is either 22.6 degrees. Well, if this is east, to get to this dashed line, I have to go north of east. North of east. So that's a possible answer. However, this can be just as correct. I could say 13 newtons, 67.3 degrees east of north. And I would be describing the exact same thing, because if I start north and I head this way, I'm going east. How many degrees? That many east of north, or 22.6 degrees north of east. Either one of those are just as correct. Okay, so that takes care of the first adding of those things, and it looks like part B is a right triangle also, so you should be able to do that. Okay, then it wants to look at the next one, and it says vector components. That's just the legs of a triangle, piece of cake. So if I look at 22 meters per second, and they were nice enough to give me a, I can't tell, maybe that's a 43, 43 degrees right there. 43 degrees. So I need to find this leg and this leg. Notice how I've drawn my heads like this because this vector is showing me I'm in the first quadrant, so I'm to the right and north, or east and north. So I'm going to find this side. This is lying on the y-axis. So I'm going to say, I'm going to call that y, and I'm going to say that the sine of 43 degrees is equal to the side opposite y over the hypotenuse, 22. So I'm going to multiply the sine of 43. Make sure your calculator is in degree mode. I can't say that enough. Sine of 43 times 22. And I got 15 meters per second for my y. 15 meters per second, and it's to the north, so I'm going to indicate that right there. Because it's a vector, I need a magnitude and a direction. Alright, x is going to be the cosine of 43 degrees is equal to the side adjacent, which I'm going to call x, over the hypotenuse. And so I'm going to take the cosine of 43, and I'm going to multiply it by 22, and I should get 16.1 meters per second. And it's to the east, or to the right, whatever you want to call it. Now I'm checking to see if this is reasonable. If this is 43, this is 47. The larger leg of the triangle should be opposite the larger angle, and it is. 16 is greater than 15, so I know I'm pretty good to go there. So that's how you do components. They're just the legs of the triangle. Pay attention to their direction. Alright, now number 3 says a jogger travels due south. So he's headed that way. Then he jogs due west, like that. And then he has a total displacement of 7.41 kilometers. So remember, displacement is change in position from beginning to end, 7.41 kilometers. And I knew that this one was 4.68. Then to find this westerly displacement, I'm going to do the square root of c squared minus a squared equals b squared, or b. So that's no big deal. You can handle that. Alright, what angle does this total displacement vector make with due south? So here's my angle, theta. Alright, so I need to find that angle. So I should be able to say the cosine of theta is equal to the side adjacent over the hypotenuse. And again, watch your units because they should always cancel out if you're doing sine, cosine, tangent, because those are just sweet little ratios. So 4.68 divided by 7.41. Second cosine, second answer. I get 50.8, which is exactly what they get. Theta is 50.8 degrees with south. So there we go on that. Not a big deal. Finish up the rest. You should be good to go. Alright, firefighter, 12.2 feet up a ladder. So hopefully the ladder's leaned against something. And 7 degrees with the horizontal. So this is the horizontal. Make sure you know which is vertical and horizontal. Don't freak out on a test and get them confused. Okay. What are the horizontal and vertical components of his displacement? So they want to know what is y and what is x. So again, it's very much like what we just did with number 2 up there, vector components. That should not be a big deal for you. Alright, a gondola ski lift at Keystone, Colorado is 2830 meters long, 14.6 blah blah blah. So again, here's the gondola, 2830 meters long. Tells us that it makes an angle of 14.6 degrees above the horizon. So here's my 14.6 degrees. How did I know that? Because here's the horizon and they went above it, 14.6 degrees. And they want to know, come on iPad, turn on. They want to know how high is the top of the ski lift relative to the base below. So they're asking you for this right here. Not a big deal. Use your sine function, go for it. Okay, number 6, a beautiful swan swimming in a beautiful river, current of 3 meters per second to the west. So there's the river. The current is flowing to the west. Heads 90 degrees north and swims at 2 meters per second relative to the shore. So this is the Swan trying to do the 2 meter per second thing. So they want to know what will be the velocity relative to the shore. I don't know how they're going to get 36 because you have 3 and you have 2. So that's 3 squared is 9, 2 squared is 4, that's 13, the square root of 13. Maybe it's 3.6, let's see. Second square root, 13. Yeah, the decimal's off. So here's what I did. Let me read this again. Yeah, so they're asking you for this right here. And then I guess they want the angle with the shore right here. So let's go for it. So that's going to be 2 squared plus 3 squared is 13. Take the square root of 13 and you'll get the 3.6 meters per second. And then I would find this little angle right here because I always want the angle with the 2 tails, and then I'd say 180 minus that is where the 146 came from. So try that. Alright, let me see how I'm doing time-wise. Okay, I'm going to start a new recording.